My name is Joan. I'm a Scala developer for, I don't know, close to 8 years now. And today we're going to speak about functional DevOps with Scala and Kubernetes. So yes, people usually when I tell this title, they are a bit like, what? Scala for DevOps, but yeah. So I'd like to start this talk with a quote from Cesar. He's actually laughing because he's here and he's like, what the hell is going on? So he tweeted, we use strong typing to write better code for apps, and we preach architecture as codes, yet we often end up writing CI/CD jobs in a weakly typed language like Bash or Groovy. That's what Jenkins people do, right? So who has done some sort of DevOps here, like even just deploying something or whatever? Sounds like almost everyone. And who has done it in a functional way? No one. So you guys are using Scala functional programming, but you're not using it for DevOps, right? Good. So let's try something new. Let's do DevOps with Scala. Let's make a use case. So like the most simple ever use case. So we're just going to deploy a backend API. Probably a REST API that can be accessible from internet, and this backend API is going to probably persist stuff in a database and query it back. So right, really simple. So as a DevOps, I probably need to ask myself those questions: what I'm deploying. So here it's pretty simple. I'm just going to deploy a backend API and a database. Where I'm going to deploy it, is it going to be on-premise, on a Kubernetes cluster, or is it going to be a managed service, for example, for the database? How I'm going to deploy it, if it's on Kubernetes, probably it's going to be Docker containers. If it's on-premise, like RPM and so on. We're probably going to have configuration, auto-scaling, maybe credentials for accessing the database. We probably want multiple environments for testing and production and so on. And this is going to create us some extra tasks like running migrations. We always need at some point to run migrations. It's unfortunate, but this is the way it works here. And we probably need to copy data. So for example, if you want to copy a subset of your production environment to your test environment, just to try out stuff. And if you're in a blue-green environment, you probably need to switch load balancers. So this is basically what DevOps is, right? So I said we're going to do it with Scala, but I didn't say which framework. So this talk is mainly about Orchestra. So this is so I'm the author of this library that we created when I was working at DriveTribe. I'm not anymore, by the way. And so Orchestra is a CI/CD framework. As a library. So just like HTTP is a library, you just create a project, you depend on it, and then you just write your services on it. It's the same, you just create your project with SVT and then you depend on it and you write your jobs. So because of that, it's completely code, you can Git version it, do pull requests and everything, as you're used to. It's extendable via any Scala or Java libraries. And on the operational side, it's fully scalable and highly available. All right, so before doing any deployment, we probably need an environment. So we're going to create probably a staging environment where we're going to deploy continuously the master branch on it. And once we are sure that the version we deploy on staging is working, then we deploy it on production, only if we are sure, in theory. And maybe you want dev, QAs, whatever the name you give to them. So here is some code. So this is a job in the Orchestra framework. So the job is in two parts, the board and the actual job. So the board is a UI element. So we're going to have a web UI, like any CI/CD, and this is going to describe the UI basically. So we have a type of board is a job board, The first type parameter is the function that we are going to run when we click run on the UI. So here we're just going to run a function from string to unit. It's the most simple use case. We need to give a job ID, a unique ID across the CI, across all your jobs, and a nice name for the UI. Then this is a list of parameters that we need to give. Parameter in the sense that, in the UI sense, so like in the form, checkboxes, inputs, and so on. So here we have a we have an input of string. We give it a nice name. So we're gonna create an environment. We just need the environment name. Then we have the actual job. The actual job just takes a board, and then the actual function that we're gonna run when we click run. So the first implicit word here, parameter, is so basically, I'm not going to dive too much into that because I'm not going to like talk too much about that. But because this is DevOps, we're probably going to manipulate files. We're going to run shell scripts maybe, and all of that is depending on the working directory where you are. So because we want to be as much referentially transparent as possible, this object is going to provide us this context. So you can ignore it for now. It's we're not going to talk too much about that. So then we have the environment name that the user is going to pass via the form, and then we just run that function. So here I'm not going to dive too much into how we create an environment, but basically it looks like we're using Kubernetes here, and we create a namespace with the environment name. That's the first line here. And then we deploy Elasticsearch. You don't need to know how it is there, in there. And we have a timeout of 1 minute for doing all of that. Are you okay with this? So once we created an environment, we basically end up in this state. So we have everything except the backend API. The database is deployed and everything. So now we can do a deployment. So this is the deploy backend job. Pretty much the same thing, except here we have a function from string to unit. And because we have two parameters here, we give two input strings. So we want to deploy a specific version from. So we want to deploy a version to an environment. So we just give a version to which environment we want to deploy it, and then the function is pretty simple. We just back and deploy that version to that environment. I'm not going to dive too much into that. But before doing any deployment, we probably need to publish a version. So let's do that job that publishes backend. So here the signature is so git ref boolean to string. So basically the git ref, I should have done that before. We want to be as typed as possible instead of using strings or like primitive types. So git ref is just a case class of any val, just wrapping a string basically. So it's going to represent the commit or branch that we want to build from. And then the boolean is, so notice here that we are using a checkbox because it's a boolean, and we want to probably run the test or not. By default it's checked, but it's always good to have the ability to uncheck, to not run the tests when when production is down and you need to deploy a fix quickly. So you just uncheck the test so you go quicker. It's always in those situations that we should not uncheck that box, but we always do that. So and so yeah, we just run the publish job, right? So notice here we have. I'm just going to do the pointer here. So everything is type checked. Here we have a git ref and a boolean. You cannot swap the input and the checkbox; it won't compile. So this is all type checked. And also here, this value git ref is of type git ref, and run check is of type boolean. So I know it sounds like pretty normal to have the types, but if you look out to all the other CI, I don't know any one of them that type things. So it's always a string, and then if it turns out that it was a boolean, you just need to pass it like to boolean, whatever. You don't have any type safety whatsoever. And the return type here is not a unit anymore. it's a string, so we just basically, this function returns the version of the published artifacts. So you'll see later why I'm pointing that out. So, well, basically I want to, whenever we do a change on master, we push on master, or merge a PR, I just want to, the CI CD, I don't know, CD, probably, to just pick up the change and deploy, ship the thing, basically. Maybe not like that, but yeah, just ship it. And so we probably need a job that publish and deploy all at once. So here, yeah, we just get the git ref, if we want to run the test or not, to which environment we want to deploy it. And then notice here that we can actually trigger other jobs. So we just reference them, and we can call .run on it. We give the parameters that we want to give to that job, and then we can pull that string I told you. So that's the version, and then we can run the second job here. All right, so we have, that's all the jobs I was going to show you. Now we actually need to run the server, right? We wrote those jobs, and to do so, we just need to extend Orchestra server, and by doing that, you will be forced to implement board and jobs. So again, board is the UI, jobs is all the actual jobs. So board is actually going to be compiled to Scala.JS, to JavaScript really. And here another type of board is a folder. You give it a name. Usually people give the name of their company here. And then we just put all the boards flat here. We need to register the jobs here. You can nest things if you want. If you want like a folder in a folder, you can nest, like organize your thing as you want. It's going to be the UI basically. And so I said when we push to master, we want it to pick up the change and deploy it. So we have a plugin. Currently we just have GitHub hooks. So you just extend GitHub hooks, and then you need to implement GitHub triggers. So here we just give, you can give as many triggers you want, but here we have a trigger branch, a branch trigger, sorry. We need to give the repository that we want to watch. The branch, so here it's actually regex, but we don't need that regex, so we just give master, which job we want to run. And we need to give the default parameters which are not git ref. So basically we want to run the tests and we want to deploy to staging. That's it. So let's have a look at how the UI looks. So yeah, well, all the jobs, right? You create the environment, give it a name, just run it. It's not the most fancy UI. Let's say we managed to make it worse than Jenkins. I think it's fair. But I think to maintain it, it's much easier. It's I mean, Jenkins is always some stuff are going on. You don't understand why. And so how does it work? So I said it's a library. So you just create your project with SBT. I mean, you can use something else if you want. But then why doing DevOps with Scala? And you depend on Orchestra. So because it's just an SBT project, you can basically depend on, so you know, all those CI have stores of plugins. For Orchestra, the store is Maven Central, so you can depend on any of them. For example, we're using a lot of AWS because we are in AWS most of the time. I guess most of you are on AWS. We just use the Java SDK of AWS, and then you package it to a Docker image, and you deploy it on Kubernetes. So I managed to talk all the way here without speaking about Kubernetes, whereas it's in the title. So the reason why, so Orchestra has a strong coupling to Kubernetes. Why is that? It's because Orchestra is doing almost nothing. Yeah, it just basically, it's just a client and the UI for Kubernetes, because Kubernetes has all this concept of jobs, the secrets, Orchestra is just running container, your code in a container, and all the scheduling on the machines, on the cluster is done by Kubernetes. So that's what makes Orchestra so reliable, because it just relies on Kubernetes, and it's a Google-proven technology. So here is a Kubernetes cluster empty. So by default, when it's empty, it's actually, there's some services, including Kube API. So for those who are not familiar with Kubernetes, basically Kube API is just a REST API where you basically always chat with this API to tell, hey, run this container, kill this container, run it, and so on. All the stuff is done via this part. So via the Kube API, you deploy your newly built Orchestra container. So Orchestra uses Elasticsearch as a backend storage. We need to store the logs somewhere. So most of the time, we just deploy it on Kubernetes. It's easy to deploy. It's just a YAML file. You just apply it. It's done. And then next time you go on with your browser on the UI, like we did just before. Well, it was a GIF, but yeah, it will just pull the history from Elasticsearch, all the logs from Elasticsearch, so just simple stuff, right? So it's just important to note that your Orchestra here, that container, is completely stateless. You can spin 20 of them if you want. If it's down, it's just the UI is not going to be there, but it doesn't manages all the nodes. There's no management at all. So let's say you click run, you run that job. What it's going to do is, first of all, it's going to write in Elasticsearch, hey, it's going to say, I want to run that job with those parameters, so it just writes the parameters there. And then it tells to Kube API, run that job, like Kubernetes job, so it's a container. And what Kubernetes is going to do is, it's gonna deploy, so run the same container as this one, but with some environment variable to say, I want to run that job. You know that ID that you gave to the job? It's passing it via environment variable to say, hey, run this one. As soon as it starts, it will, you can see the pizzas. So it will just run the function that you gave, and it will just dump all the logs to Elasticsearch. And then next time you go on with your browser to see the state of your job and all the logs, you're just going to go through Elasticsearch. So you can see that this master, it's not a master. It doesn't manage anything, so it can go down. If you release a new version of it, it's not going to bring down all your jobs. It's just going to replace this one, and then next time you run a job, it's going to be that new version. So I just want to... So I spoke about AWS. So here is an example. You just depend on the AWS SDK, and then you can do upload to S3, whatever you need to do with AWS. Another example is, I mentioned about copying data over. So copying data from prod to your staging, for example. Every week, sometimes we just subset prod to staging to have a fresh environment. So most of the time, your logic is going to be, you have your model in your actual backend app, in your backend code. So if you're lucky enough to have it in Scala or Java, actually, you can depend on it on your backend, basically code, and then you can just run functions out of, just like that. Before, I think most of people just do a command line tool, and they just run the command line tool from their CI. Here is all type safe. So, for example, service is coming from that dependency, and then you can just run copy data as a function. So it's pretty cool. Well, that was Functional DevOps. So this talk is highly inspired from that article I wrote. If you didn't understand some parts, or you actually understood everything and you want to go further in, you can read that article. I just show the minimum. There's so much helper methods and many things you can do with Orchestra. I didn't even speak about pull requests, validation, I mean many things. All the code I showed, and which is in this article, is there. And all the documentation is on orchestra.tech. And so, yeah, I forgot to say, so just DriveTribe is the company where we used to work, where I developed it, and they are using it pretty happy, it seems to. Yeah, just thanks to them for open sourcing it.